Hello, welcome to DevOps Underground. We have Amin here today. He's a DevOps and cloud consultant at Kloya. Amin,
Yeah,
why do you tell us a little bit about yourself?
of course. Hello, everyone. My name is Emin, and I am currently working at Kloya as a cloud and DevOps consultant. My main focus is on AWS or and enterprise Kubernetes environments like on cloud or on premises. This is this is kind of short introduction. Yeah.
All right, we have the idea. Are you ready?
Yeah, of course.
Go for it. The stage is yours.
Thank you. I started sharing my screen. Is it on now or?
Not yet. I can't see it. 1 second. There we go.
Yeah, there
Perfect.
we go. Perfect. Yeah, thank you. So I'm going to talk about a CNCF project called Longhorn today. This is a project and provides persistent storage for Kubernetes clusters actually. So let me just talk about myself again. My name is Emin, like I mentioned before. I'm holding some certificates about AWS and Kubernetes and some other tools as well. I'm trying to actually make people excited about DevOps culture and DevOps tools and in this cloud native world actually. Just briefly, I just want to talk briefly about Kloya as well. Kloya is a consulting company on DevOps, cloud, and microservices. We have more than 40 consultants in those areas actually, and of course test automation as well. I just forgot to mention that. We have offices in London, Amsterdam, and Istanbul, and we have clients more than 13 countries. We are a CNCF Silver member. We are AWS Advanced Partner. We are Rancher Partner. We have some other partnerships as well. So for today's agenda, we're going to discuss first what is Longhorn, and we are going to discuss the architecture of Longhorn and how Longhorn works actually. We're going to discuss Longhorn use cases after that, and we're going to discuss Longhorn concepts and best practices. And after all of these presentations, I have a little demonstration that I want to show with you. So, by the way, you can stop me anytime if you have some questions, or we're going to have some Q&A sections in the end too, but please let me know. So what is Longhorn? Longhorn is a free open source software. It is originally developed by Rancher, and it's now being developed as a sandbox project of the Cloud Native Computing Foundation, CNCF. Actually, that means it's developed by Rancher and donated to CNCF. It's a lightweight, reliable, and easy to use distributed block storage system for Kubernetes, actually. So we are trying to extend our Kubernetes usage, and we need some persistent storage for our stateful applications running on top of Kubernetes clusters. So Longhorn is one of the solutions for that. So if we look at the Longhorn's feature, before that, I just remembered the product was launched in 2014. It has now plus 1 million downloads per month, and it has more than 10K stars on GitHub as well. So if we look at the features, you can use Longhorn volumes as persistent storage for the distributed stateful applications running on your Kubernetes clusters. So you can partition your block storage into Longhorn volumes so that you can use Kubernetes volume with or without a cloud provider. And you can replicate block storage across multiple nodes and data centers to increase availability. You can store backup data in external storage such as NFS or AWS S3 or any S3 compatible object storage environments. And you can create cross-cluster disaster recovery volumes so that data from a Kubernetes cluster can be quickly recovered from a different Kubernetes cluster running anywhere, actually. That they just need to access to backup target like NFS target or S3 target, and you can create disaster recovery volumes using that feature as well. It's built in to Longhorn. You can schedule recurring snapshots of a volume, and you can create schedules for backups as well to NFS or S3 compatible secondary storages. And of course, you can restore volumes from those backups, and you can upgrade Longhorn without disrupting any persistent volumes because it has built-in high availability inside a cluster. So if we look at the architecture diagram here in the slide, in the figure, there are 3 instances with Longhorn volumes, and each volume has a dedicated controller, which is called the Longhorn engine and runs as a Linux process, actually. Each Longhorn volume has 2 replicas, and each replica is a Linux process. The arrows in the figure indicate the read and write data flow between the volume, controller instance, replica instances, and disks. By creating a separate Longhorn engine for each volume, if one controller fails, the function of other volumes is not impacted by that failure, actually. In high level, the Longhorn design has 2 layers, actually, the data plane and the control plane. The Longhorn engine is a storage controller that corresponds to data plane, and the Longhorn manager corresponds to the control plane. The Longhorn manager pod runs on each node in the Longhorn cluster as a Kubernetes daemon set. It is responsible for creating and managing volumes in the Kubernetes cluster and handles the API calls from the UI or the volume plugins for Kubernetes. So it has built-in high availability within a cluster by having some replicas for each volume. You can, of course, change the default replica count for your volumes, and each replica is running on different nodes. If you lose one node, you won't be affected by that failure. If you know the storage architectures, there are some provisioning types, tick provisioning or team provisioning. Longhorn uses actually team provisioned storage system. When you think about it, tick provisioning storage systems are pre-allocates the storage, underlying storage, even if you don't have any data on that space. But Longhorn uses a team provisioning system. That means if you only just write data to the volume, it'll take those storage space. For example, like you see in the slide, if you allocated a 20 gigs volume but only use 1 gigs of it, the actual data size on your disk would be 1 gigs. But a Longhorn volume itself cannot shrink in size if you've removed content from your volume. For example, again, if you created 20 gigs of volume, use 10 gigs of it, then remove the content of 9 gigs, the actual size on the disk would still be 10 gigs instead of 1 gigs. This happens because Longhorn operates on the block level, not the file system level. So Longhorn doesn't know actually if the content has been removed by a user or not. That information actually is mostly kept at the file system level. By the way, there are some feature requests and issues on GitHub about this. One of them is opened by me, actually, because it can cause some problems because if you're taking snapshots of a volume, the actual size of the volume can increase without you noticing it. So because of that, I have opened the feature request and issue on GitHub about this as well. So let me talk about how Longhorn works. So when the Longhorn manager is asked to create a volume, it creates a Longhorn engine instance on the node the volume is attached to. And it creates a replica on each node where a replica will be placed. Replicas should be placed on separate hosts to ensure maximum availability, of course. The multiple data paths of replicas ensure high availability of the Longhorn volume. Even if a problem happens with a certain replica or with the engine, the problem won't affect all the replicas or the pod's access to the volume. The pod will still function normally. So Longhorn Manager communicates with the Kubernetes API server to create a new Longhorn volume, CRD, and the Longhorn Manager and the engine handles the rest of the volume creation, actually. So let's look at some main use cases of Longhorn. Longhorn actually delivers simplified, easy to deploy and upgrade 100% open source cloud native persistent block storage without the cost overhead of open core or proprietary alternatives. It is 100% open source, free to use, but you have the option to purchase some enterprise support subscription from SUSE as well. Longhorn's built-in incremental snapshot and backup features keep the volume data safe in or out of the Kubernetes cluster. You can, like I've mentioned before, you can create scheduled backups of persistent storage volumes in Kubernetes clusters. It's really simplified with Longhorn's intuitive free management UI. And you can when you're using Longhorn, you can control the granularity to the maximum. Actually, you can easily create a disaster recovery volume in another Kubernetes cluster and fail over to it in the event of an emergency or a failure or a disaster. If your main cluster fails, you can bring up the app in the DR cluster quickly with a defined RPO and RTO. So when we look at the concepts, there are some concepts behind Longhorn. First one is replicas. The second one, snapshots, backups, disaster recovery, and volume expansion. So we're going to discuss each of these, separately, in separate slides, of course. Don't mind the, cow Longhorn, and there are some more concepts too, but these are the main concepts we should all know, we should all learn. Let's start with replicas. As you can see, for each Longhorn volume, there are, like I've mentioned before, multiple replicas of the volume that they should run in the Kubernetes cluster, each on a separate node. All the replicas are treated the same, and Longhorn engine always runs on the same node as the pod, which is also the consumer of the volume. In that way, Longhorn makes sure that even if the pod is down, the engine can be moved to another pod, and your service will continue undisrupted. The default replica count can be changed in the settings. I've said this before, but when a volume is attached, the replica count for the volume can be changed in the UI for, increasing high availability. If the current healthy replica count is less than specified replica count, Longhorn will start rebuilding new replicas. And if the current healthy replica count is more than the specified replica count, Longhorn will do nothing actually. In this kind of situation, if a replica fails or is deleted, Longhorn won't start rebuilding new replicas unless the healthy replica count dips below the specified replica count, let's say. The snapshot feature, it's like an usual snapshot feature we see on other storage systems or other systems. The snapshot feature enables a volume to be reverted back to a certain point in history. Backups in secondary storage can also build from a snapshot as well. When a volume is restored from snapshots, it reflects the state of the volume at the time the snapshot was taken. It's like a screenshot, but but we shouldn't consider snapshots as backups. The snapshot feature is also a part of Longhorn's rebuilding process. Every time Longhorn detects a replica is down, it'll automatically take a system snapshot and start rebuilding it on another node. It's just a snapshot is just like a layer of an image with the oldest snapshot used as the base layer and newer snapshots on top. The data is only included in a new snapshot if it overwrites data in an older snapshot. Together, a chain of snapshot shows the current state of the data, actually. But like I've mentioned, we shouldn't consider snapshots as backup solutions, because taking a snapshot is actually easy, but reverting back to an older snapshot or deleting some snapshots can cause some problems, because when you take a snapshot, the volume head is actually going to be after the snapshot time, and you're going to write data to the latest snapshot. And when you try to delete some of the snapshots in the chain, it'll automatically start merging the newest data to the older states, older snapshots, or base image actually. So when we look at the backups, a backup is created using one snapshot as a source, so that it reflects the state of the volumes data at the time that the snapshot was created. Snapshots is just a tool for taking backups, actually. But by contrast to a snapshot, a backup can be thought of as a flattened version of a chain of snapshots. Similar to the way that information is lost, when a layered image is converted to a flat image, data is also lost when a chain of snapshots is converted to a backup. In both conversions, any overwritten data would be lost. Uh, because backups don't contain snapshots, they don't contain the history of changes to the volume data. So after you restore a volume from a backup, the volume initially contains one snapshot. This snapshot is a conflated version of all the snapshots in the original chain, and it reflects the live data of the volume at the time the backup was created. So while snapshots can be terabytes in size, backups are made of just 2 MB of files. Each new backup of the same original volume, by the way, is incremental. It is automatically detecting and transmitting the change blocks between snapshots. So you won't just take initial backups every time. It's like incremental backup. All right. So when we look at disaster recovery side, as you can see, there are two guys, behind, waiting if something happens to the guy in the front. A disaster recovery volume is a special volume that stores data in a backup cluster in case the whole main cluster goes down. DR volumes are used to increase the resiliency of Longhorn volumes. A DR volume can be created from a volumes backup in the backup store. After the DR volume is created, Longhorn will monitor original backup volume and incrementally restore from the latest backup. A backup volume is an object in the backup store that contains multiple backups of the same volume. If the original volume in the main cluster goes down, the DR volume can be immediately activated in the backup cluster. So, it can greatly reduce the time needed to restore the data from the backup store to the volume in the backup cluster. When a DR volume is activated, Longhorn will check the last backup of the original volume. If the backup hasn't already been restored, the restoration will be started and the activate action will fail. Users need to wait for the restoration to complete before retrying, actually. So if you have two clusters, if I summarize this scenario, if you have two clusters accessing the same backup target, same backup target, it can be S3 compatible object storage or an NFS target. If those clusters have access to the same backup target, you can create disaster recovery volumes from backups that you originally took from the primary Longhorn cluster in the secondary cluster. So you can reduce to RTO and RPO by immediately restoring the volume from the disaster recovery cluster. It's a built-in feature. You don't have to deploy any third-party solution or any other Kubernetes object to your cluster for accomplishing these kind of disaster recovery scenarios as well. That counts for backups too, or snapshots too. If you look at the volume expansion, you can expand your volume size. Volumes are expanded in two stages. First, Longhorn expands the front end. That means the block device. Then it expands the file system. Sorry. To prevent the front end expansion from interface by unexpected data read or write operations, the Longhorn actually supports offline expansions only. So you have to detach the volume before expanding the volume actually. So rebuilding and adding replicas is not allowed during the expansion, and expansion is not allowed while replicas are rebuilding or being added to the volume. So it has a maintenance period when you try to perform those two actions together. It will not work. There are two ways to expand the Longhorn volume. The first one is the person volume claim, of course, using a YAML file or using a Kubernetes object. And the second one is with the Longhorn UI. You can actually expand the volumes from Longhorn UI as well. So thank you for listening. If you have any questions, I can answer them right now. I believe.
I think there might be an issue with questions in the channel actually, but if you can't post in the channel, please feel free to post on the meetup page, and we'll make sure to transfer the questions to Amin.
Yeah.
Thank you so much for your talk today. It was fascinating. I love the idea of in storage. That's really efficient.
Yeah. Thank you.
Right.
If there are any questions, I can answer them, or I can move on with the demonstration. I just put on my Rancher t-shirt. I'm ready to go.
Go for it.
All right. Like I've mentioned, if you have any questions, please, I'm just going to start the demos right now. Yeah. Let me go to the UI. Can you see my screen still? For example, should I change this to the light mode or the dark mode? I believe light mode.
Both are fine.
Yeah.
Both clearly.
Yeah. All right. So I have a Rancher cluster. It's built on an RKE cluster. It's running a Kubernetes version 1.21. And I have installed Rancher on top of it, and I have installed Longhorn and Rancher's. Longhorn and Rancher's monitoring system is like this is a Prometheus operator. It's running on top of Rancher as well. So let me show some information about my Kubernetes clusters. As you can see, there are 3 nodes. The version is 1.21. It's running on Ubuntu 18.04, and I have created. Let me show the namespace. I have created as you can see, Rancher on Cattle system namespace. We have the monitoring system namespace that runs the Prometheus operator, and I have installed Longhorn system on top of this cluster as well. We can see the pods running on Longhorn namespace. Yeah, there are a lot of pods actually running, but as you can see, there are 3 managers. Actually, we should see the wide option. There are 3 managers running on 3 different nodes for actually in cluster high availability. So Rancher is running like that as well for. So they are running on different nodes as well. So let me go back to UI. For I have created the you know the resources beforehand, so we shouldn't lose time here. But you can install this is by the way Rancher version 2.6. You can install cluster tools from here for each of your clusters. I have just installed Longhorn and monitoring stack. This is a Prometheus operator. It installs Prometheus node exporters or other exporters for parsing the data from your Kubernetes clusters. It deploys Grafana and it has some built-in pre-built dashboards for you, and it deploys alerts manager as well, and you can create some it has some predefined alerts for you as well. So let me just go back to Rancher. Uh, Within the Grafana, it has, like I've mentioned, built-in dashboards for your Kubernetes objects, but I have created an example, Longhorn dashboard for you too. As you can see, we can see the number of volumes, number of healthy volumes, volume sizes, and capacity information. And we can see node information from this dashboard as well. We can see the actual disks and the disk space usage or capacity, and we can see CPU and memory usage from nodes as well. But there are no data in here. I don't know why. And after installing Longhorn, let me just show you how to install it. I'm just going to edit it. You'll see you'll get the idea. You can choose a version from here. I have installed the latest version of the Longhorn. It's available in Rancher UI. You can just change the values from here, or you can just edit the YAML from here as well. You can customize default setting. You can just customize the storage class settings if you want to, maybe, I don't know, you retain the volumes after you can just create reclaim policies. You can change the service and load balancing types, or you can change other settings from here as well. After clicking next, or it just starts installing the Longhorn system to your Kubernetes cluster, and you can just access the UI from here. It is already opened right now in the other tab. I have 6 volumes, and you can see it in the dashboard. This is the default dashboard, actually. You can see the storage size, you can see the node count or volume count from here. You can see event logs from here, what happened to your Longhorn cluster. You can see the node information from here as well. allocated storage or used storage, those kind of stuff. You can see your volumes from here. You can see backups from here. And of course, you can change the settings for your Longhorn volumes from here as well. In the presentation, I've talked about backup. So for taking a backup of your volumes, you just need to create a backup target. I've just created a S3 bucket. It's just an empty S3 bucket right now. As you can see from here, there are no data in it, in this bucket. And you just need to create a Kubernetes secret for Longhorn to authenticate with S3 to send data to that bucket actually. So for for this demo, let me show you from the UI. I just deployed two applications. One of them is ClickHouse. ClickHouse is the DB, and I have deployed. Where is it? Let me just go into pods as well. Yeah. This is an operator for ClickHouse. There are 3 replicas of the ClickHouse DB deployments. They're all running on different nodes, and I have installed a Zookeeper cluster and with 3 replicas, and as you can see, they are all running on different nodes as well. You can see the volumes. These are just size 1 gigs of volumes, and their actual size are 48 to 50 megabytes, because there are no data inside of them. So you can just go into the volume itself. You can see the replica information. You can see the volume details from here. There are two size related sections in this UI. The first one is the allocated size from the disk. You can see and you can see the actual size, actual data inside of these volumes. And you can see the access modes for those for this volume, and you can see the snapshot and backup informations from here as well. There are some system hidden snapshots when you take a backup of a volume. Of course, it'll create those backups from snapshots. So system automatically will create a snapshot even without you noticing it. So if you have any schedules for snapshot and backups, you can see them here, or you can create some new schedules, daily backups, or hourly backups for your volumes. And you can see the snapshot and backup list here for each volume, and you can see the event log for each volume from here actually. So I'm going to move on to terminal. So let me just clear the screen again. Yeah. So like I've told you, I have a deployment called ClickHouse. I'm just copying and pasting some commands. Those are long commands, but I'm going to exec into one of the ClickHouse pods, the 000 pod, and I'm going to just touch a file, create a text.txt file inside of that pod. When you actually, let's just That's the file. If it's there, as you can see, the file is there right now. It has created the text.txt file inside of this pod. So let me just create a backup for this volume. This is the pod that we have written the data. I'm just going to choose the volume and create backup. I'm just going to name him. Let's just say DevOps Underground. You can create manual backups or recurring backups as well. It's going to create the backup. It'll show up here, as you can see. It has created. You can see the last backup or created at informations. You can see if it's bound or detached. I believe it'll show up here as well. As you can see, it has automatically created a folder for me in my S3 bucket. In this folder, we can see volumes. There are some folders, and as you can see, we can see backups, volume configuration, or blocks in S3 bucket as well. So let me go back to Longhorn UI. So we have created a backup of our volume with some data written inside that volume. So I'm going to just remove the text that takes the file with RM. So the file is no longer there. We have just deleted the data. No such file or directory. So in order to restore the backups, I'm just going to delete the application as well. The ClickHouse application as well, the DB application as well. So I'm going to delete ClickHouse installation in ClickHouse new namespace. For seeing a disaster scenario. If you look at the Longhorn UI, we can see the volumes are detached right now. They're going to, it's going to destroy these volumes as well, because the default setting for the retain policy is now delete, as you can see from, where was it? I believe it was in the Rancher UI, I believe. Detached. So we're gonna have just 3 volumes for Zookeepers in here, but we have our backup, as you can see. Yeah. This is deleted. ClickHouse, installation is now deleted. So I'm going to restore from our backup. So I'm going to choose the access mode, read write once. I don't have to change anything as well. Here, I'm just going to restore the backup. We can see it's now started to build the volume. Yeah, not ready for workload because it's in now maintenance. It's in now maintenance mode. The actual size is changed because we had some data within this volume. Yeah, it's now created. So after that, I have some files here. If we go to Longhorn demo cluster, and I'm going to go to ClickHouse backup and restore, I have two files here. One for PVs, persistent volumes, one for persistent volume claims. I'm going to change the PV configuration. Yeah. So as you can see, it has the 1 gig storage capacity. Access mode is read-write once. Persistent volume reclaim policy is retained. We're using Longhorn CSI driver. We are, declaring that we want 3 replicas, and we have to just change this part, because it should match. It must match the volume name from Longhorn. So I'm going to copy the volume name from Longhorn UI that we have created from our backup, and I'm going to paste it in here. So I don't have to change anything else. So I'm just saving this file. If you want to look at the PVC configuration as well, I can show you that. There's nothing, magic going on here, actually. We have just, specified the access mode, and we have just specified the request and storage class name and volume name. But this is important. The volume name and storage class name should match with the PV configuration as well. So I'm going to create these files. And PVC as well. So I'm going to, let me just go back. And I'm going to apply the application YAML as well. So I'm going to install the application again. It has now created. So if we go to Longhorn UI, we can see it is now attached to the first pod in our ClickHouse cluster. It's going to create other volumes too. You can see from Grafana UI, there are some changes as well. And you can create alerts for, actually, if you want to go here, you can create some. Let's just wait for it. Yeah, it has created the second one, and it's attaching the volume to the second pod. It's now healthy. We can see that. You can see the changes from here as well. If you want to monitor it. So it has created Longhorn created the third volume and attached the third volume to the third replica. Of our deployment, as you can see, those ones don't have any data inside of them other than the system data, of course. And the first volume has our data. Let me just show you the, if we, run the ls command inside the container, inside the same pod, we can see the text.txt file is there after restoring the backup. And yeah, if there are any questions I can answer, just
We had one question in the channel actually. In which state is Longhorn, and can I use it outside of Kubernetes?
Longhorn is built for Kubernetes, actually. Longhorn is just a storage solution for persistent storage needs in Kubernetes environments, cloud containerized environments, actually. So I believe you can't use it outside of Kubernetes at the moment, but there are some solutions that Rancher is now building some. For example, there is a solution called Harvester HCI. It's a hyperconverged infrastructure solution. It's running on top of Kubernetes as well, and hyperconverged infrastructures are bringing together the compute, storage, and network components, and it uses Longhorn as a storage backend, so you can attach volumes to your VMs running on top of Harvester. Uses Longhorn for that storage need, but Harvester is built on top of Kubernetes as well. So that means that means probably it won't work outside of Kubernetes. Yeah, at the moment.
Makes sense. Thank you.
Yeah. If there are any questions, we can look at them as well.
There's nothing else at the moment. As always, you're free
Yeah.
to post on the Meetups page. We'll
Yeah.
make sure to pass the questions to me. Thank you very much for your time today. It was great to have you with us.
Thank you so much for having me, of course.
Thank you. Bye. Have a really good evening.
Have a nice evening. Bye-bye.